The AS Applied paper, May 2018, question 9. Two small balls, P and Q, have masses 2m and km respectively, where k is less than 2. The balls are attached to the ends of a string that passes over a fixed pulley. The system is held at rest with the string taut and the hanging parts of the string vertical, as shown in figure 1. The system is released from rest and, in the subsequent motion, P moves downwards with an acceleration of magnitude 5g over 7. So we know that P moves down magnitude of 5g over 7, and so therefore Q is going to move up with a magnitude of 5g over 7. The balls are modelled as particles moving freely, the string is modelled as being light and inextensible, the pulley is modelled as being small and smooth. Using the model, find, in terms of m and g, the tension in the string. So if we're going to look at doing this, the first thing that I tend to do is, even though we've got the diagram there, I'm going to draw my own one out. So we've got a pulley here, and we've got a mass there. We've got a mass here, so this is km, and this is 2m. Now this is P, and this is Q. So let's have a look at our forces. So we've got tension going upwards and downwards there. We've got tension here. We know that the acceleration will be going down and be 5g over 7. And we know here the acceleration is going upwards and will be 5g over 7. And we know there's a force coming down here of km, lots of gravity, and there's a force coming down here of 2m, lots of gravity. So if we want to find the tension in the string in terms of m and g, what we use is our force is equal to mass times acceleration formula. And we can say, looking at the left-hand side, looking at P, we have the force going down of 2mg, and we can then take away the tension going the opposite direction, is equal to the mass, which is 2m, times by the acceleration, which we know to be 5g over 7. So rearranging this, we get that T is equal to 2mg minus 10mg over 7. And then what we have is T to be equal to 4mg over 7. Part B. We are asked to explain why the acceleration of Q also has a magnitude of 5g over 7, and this is simply because the string is modelled as inextensible. Part C. Find the value of K. So in order to find the value of K, what we can do is look at the force acting on that side of the pulley. So what we've got from our diagram is we can say that the direction of acceleration is going upwards, so therefore we've got tension, which is 4mg over 7. Take away the force pulling down, which is kmg, has got to be equal to the mass, which is km, times the acceleration, which is 5g over 7. So looking at this, because this is multiplied, we can say there's a g and an m in every single part, and they can be cancelled out. And so we're left with 4/7 minus k equals 5k over 7. And so therefore we rearrange that, we get 4 minus 7k equals 5k, and k is equal to 1/3. Part D. Identify one limitation of the model that will affect your accuracy. To be honest, looking at this, you could say that the pulley is unlikely to be smooth. In real life, there's probably going to be friction.